My name is Keng. Today I would like to share the video presentation of my research study. The title is Comparison and Validation of the Extraction Methods for Pectoralis Major Muscle and Serum of Chicken by Gas Chromatography-Mass Spectrometry. This research is led by my supervisor, Prof. Jinab, and members Dr. Rashida, Dr. Nunzu, and Dr. Alfi. This is the presentation outline for this video presentation, including introduction, problem statement, significance of study, materials and methods, results and discussions, and conclusion. Chicken meat, gallus is produced for human consumption as protein source. The demand of chicken meat is increasing over the years due to low cost compared to red meat like beef and mutton, suitable for further processing, and no cultural or religious prohibitions. In market, there are several types of chicken produced commercially, including broiler, colored broiler, village chicken, in Malaysia we call as ayam kampung, and span-laying chickens, or ayam pencen. Globally, village chicken is having high demand and sell at a higher price compared to other breeds due to better taste, texture, and health benefits. This slide is sharing several reports regarding to food frauds of selling cheaper chicken breeds as village chicken in recent years. In this case is regarding to the selling of underage colored broiler chicken as a village chicken in the local market. Consumers are not able to distinguish the carcass between both chicken breeds due to the similarity in size and physical appearances. Food authentication is a detection process for food fraud and adulteration. It is defined as the act of confirming the authenticity of food products through the identification of product identity, origin, and composition. There are several omic approaches is applicable in food authentication, including genomics, transcriptomics, proteomics, and metabolomics. Metabolomics approach is a study of wide range of small molecules less than 1,500 daltons. This approach is a promising approach to facilitate the understanding of biochemical composition in living systems and also food. The advantages of this approach is that it is applicable for targeted and untargeted approach and is capable to analyze and interpret for complex datasets. Several analytical platforms could be used for this approach, including GCMS, NMR, LCMS, and also FTIR. This slide shows the major and minor components in pectoralis major and serum of chicken based on the literature. These metabolites are potentially and expected to be identified in metabolomic study of both matrices. As shown in the slide, the major component of muscle and serum is like the protein and water, while the minor components in both matrices are organic acid, fatty acid, nucleotide, some minerals, and vitamins. The raw dataset obtained from the analytical platform such as GCMS could be subjected for multivariate analysis for biomarkers identification in chicken breeds authentication. Besides, this metabolite is also affected by several factors such as age, species, breed, sex, the feed, and also environmental conditions such as the transportation and rearing condition. And therefore, these affecting factors should be taken into the consideration in the metabolomic study as well. This is the problem statement of this study. No official methods is available to distinguish village chicken from other chicken breeds using GCMS through untargeted metabolomic study. There are two objectives in my study. First is to compare 4 different types of solvent combinations for the extraction methods of the pectoralis major and serum using GCMS. Second, to validate the selected extraction methods of the pectoralis major and serum using GC-MS. The result of this study can be used as the validated extraction protocols for chicken breast discrimination through untargeted metabolomics study, and it could provide scientific information on the potential extraction protocols of pectoralis major and chicken serum by using GC-MS in metabolomics study. This is the research flow for pectoralis major and serum in this study. Before we compare and select the extraction methods for both matrices, pectoralis major muscle is snap freeze using the liquid nitrogen just after the slaughtering and sampling. The sample is freeze dried and kept in -80°C freezer before analysis. Same goes to serum. The collected blood samples is centrifuged for separation. The top layer, which is the serum, is collected and snap freeze using the liquid nitrogen and kept in -80°C freezer until analysis. The extraction methods is further compared and selected for both matrices, followed by method validation and sample quantification. In the method validation, several parameters are performed, including the limit of detection, limit of quantitation, linearity, repeatability, within laboratory reproducibility, and trueness. This is the extraction procedure of pectoralis major muscle for GC-MS analysis. As I mentioned earlier, the sample will be freeze-dried before the analysis. So the freeze-dried sample will be homogenized using the homogenizer, and the sample will be subjected to the centrifugation for the separation, and the supernatant will be collected and subjected to the evaporation using the nitrogen gas. And after the completion of the dryness, the sample will be subjected for the two steps derivatization using two different types of the derivatizing agent, and it will be incubated accordingly using the thermal mixer. And after the derivatization process, the sample will be filtered and transferred to the sample vial and subjected to the GC-MS analysis. In the extraction methods comparison study for the pectoralis major, we are comparing 4 different types of the solvent mixtures, number 1 until number 4. And the selected method will be further compared on the different sample weight to the solvent volume ratio. So we are comparing another 5 different ratios here. This is the extraction procedure of chicken serum for GC-MS analysis. So the extraction solvent is added to the chicken serum, and the sample is vortex and centrifuged, and the collected supernatant is further evaporated using the nitrogen gas stream until complete dryness, and the sample is subjected to the two steps derivatization procedure using two different types of derivatizing agent, and the sample is incubated using the thermomixer, and after the completion of the derivatization steps, the sample will be filtered and transferred to the sample vial for the GC-MS analysis. Similarly, the extraction methods for the serum is compared. Here we are comparing 4 different types of the solvent types, 4 different methods, and the selected method will be further compared on the different sample weight to the solvent volume ratio. This is the instrument setting for the GC-MS. We are using the HP5MS, the GC column, and we are running at a full scan mode from M/Z 35 to 600. Here is the comparison result for pectoralis major extraction methods. The 4 methods were compared based on the number of metabolites with matching scores more than 90% obtained from NIST library software. As displayed in the slide, we found that Mabuchi et al. 2019 produced the highest number of metabolites, more than 90%, as compared to the other 3 methods. In this study, the method is further compared with different sample weight to the sample volume ratio. The ratio 1 to 4, which produced the highest number of metabolites with 90% similarity, is selected in this study. This is a comparison result for the chicken serum extraction methods. So similarly, we also comparing 4 different types of the method, and we found that trimethanol et al. 2018 with the methanol produced the highest number of metabolites compared to the other 3 methods. And this method is further compared for different sample weight to the solvent volume ratio, and we found that 1 to 3 ratio produced the highest number of metabolites, more than 90%. This is a GCMS chromatogram for pectoralis major muscle extracts. The total runtime is 82 minutes. Here, several metabolites with matching scores more than 90% were labeled in the chromatogram. And this is the GCMS chromatogram for the chicken serum extracts. And the runtime also the same, 82 minutes. And we also labeled several metabolites with a matching score more than 90% in the chromatogram. In this study, the selected method for pectoralis major and serum successfully produced 49 and 62 metabolites respectively. For both matrices, the highest number of metabolites identified is amino acid, followed by other groups such as fatty acid, organic acid, and sugars. In the meta-validation, a total of 6 and 9 metabolites were applied for pectoralis major and serum using commercial standards respectively. The metabolites were selected based on the metabolites group identified in both matrices as reported in the previous slide. The LOQ for pectoralis major is in the range of 8 to 25 microgram per milligram, while LOQ for serum is 5 to 500 microgram per ml. The linearity study for all metabolites were also in the acceptable range, with correlation of coefficient value more than 0.99. From the precision study, repeatability is conducted for 3 different concentration levels by one analyst and same GCMS instrument. RSDR value was calculated for each concentration level and further compared with the predicted RSDR value obtained from the Hovis equation. As displayed in the slide, all the calculated RSDR value were less than predicted RSDR value, and therefore it is accepted in this study. Also, from the precision study, within laboratory reproducibility is conducted for 3 different concentration levels by 3 different analysts and same GCMS instrument. As displayed in the slide, all the calculated RSDR value was less than the predicted RSDR value obtained from the Hovis equation, and therefore it is accepted in this study. The recovery study was performed at 3 different concentration levels. The recovery results show that all concentration levels were within the acceptable range of 90 to 110%. This table is the quantification result of pectoralis major for both village chicken and colored broiler using the validated extraction methods. The number of replicates selected is 5 chickens per breed. The quantification results show that village chicken had higher amount of allose, leucine, and valine, while colored broiler contained higher linoleic acid, phenylalanine, and stearic acid. Interestingly, in this study, allose and leucine is only quantified in village chicken and non-detected or below LOQ for colored broiler. This is the quantification results of serum for village chicken and colored broiler. The results show that serum of village chicken had higher aspartic acid, fumaric acid, leucine, and urea. The result also show that serum of colored broiler contained higher arachidonic acid, cysteine, glucose, linoleic acid, and stearic acid. In this study, fumaric acid is only quantified in village chicken and not detected for colored broiler. As a conclusion, Two extraction methods by using GCMS were successfully compared and selected for pectoralis major and chicken serum respectively. Extraction methods for pectoralis major and chicken serum were further validated according to the Eurachem guide and fit for the intended use in chicken breeds authentication through untargeted metabolomics study. And this is the list of the references in this presentation. This is the end of my video presentation. Thank you very much.